we have a task. We actually have 3 tasks. We're being asked to graph arcsin, we're being asked to state its domain, and to state its range. Now, when I'm graphing an inverse function, it's often helpful to start with the function that it's the inverse of. I want to remember that that function is not sine. It's y equals sine x with the restricted domain. That x has to be in the interval from negative pi over 2 to pi over 2. And I could either write that out using that, it's in this interval notation, or I could just use an inequality, negative pi over 2 less than or equal to x less than or equal to pi over 2. But that whole thing is the formula for the function that we're going to be taking the inverse of. And so that's just this portion of the sine graph. Like so. And anytime I'm drawing something that has definite endpoints like that, I want to emphasize that there actually is a point there. I didn't just stop drawing, I stopped at that location. Okay, excellent. So now I want to graph y equals arcsine of x. So that's the inverse function. Well, when we graphed inverse functions, we learned that what we're doing is we're switching the roles of x and y, and we can actually do that physically if we turn and flip. This is attached to the wall. So I have here a copy of that graph. The way to turn and flip, remember, is you're going to rotate 90 degrees to the right. What that does is it takes this vertical y-axis and it lays it down horizontally. So the vertical becomes horizontal. This, what was the x-axis, becomes a vertical axis. But the problem is we've preserved the orientation that the positive direction is to the right, but here the positive direction is down, so it's upside down. So we flip it top to bottom. And I have no idea whether that's going to show up on the video or not. But if you hold it up to the light, you should be able to see the basic shape that you're getting. It looks something like this. Okay, and now that's negative 1 and 1 on the new x-axis. This is the x-axis for arcsine. It's what used to be the y-axis for sine, because I've switched those roles. And so the y values are negative pi over 2 to pi over 2. Okay. So where on the graph of sine there was a point at negative pi over 2, negative 1, on the graph of arcsine there's a point at negative 1, negative pi over 2. Again, literally switching the roles of x and y. Okay. Now that makes it pretty easy to state the domain and the range. Notice the domain would just be the interval from negative 1 to 1, including those endpoints. Okay. So I can't plug anything outside of this interval into arcsine, because what this means is essentially that sine of y equals x, and x is in the, and y is in the interval from negative pi over 2 to positive pi over 2. But that means x has to be a legitimate value for sine. Sine only takes on values from negative 1 to 1. Notice that was the range over here. The range over here was all my values between negative 1 and 1. And over here, we restricted the domain. So over here, our domain was the set of angles from negative pi over 2 to positive pi over 2, including those endpoints. Over here, that's the range. Remember, with inverse functions, since we're switching the roles of x and y, the domain of the regular function becomes the range of the inverse. The range of the original becomes the domain of the inverse. And this range is really part of the definition, because that's what's telling us that it's the inverse of this function, sine with the restricted domain. Okay. Kind of cool. So we're not going to do a whole lot of work with this graph, but it's kind of nice to see it, and I could certainly ask you to graph it. It's a pretty straightforward turn and flip. Just wanted to remind you that's how we go about graphing inverse functions.